Saxon Advanced Mathematics, Lesson 26. Our topic today is logarithms. I hear you sighing. I hear your eyeballs rolling. I feel your pulse quicken. Logarithms can be freaky, but here's the thing I want you to remember. Logarithms are exponents, and exponents are logarithms. If you understand exponents, you'll understand logarithms. I just have to translate them for you. Let me show you something that's very familiar. When we have a base with an exponent on it, we can calculate that, right? And we can get what we call a number, right? An N-U-M-B-E-R. And an example of this would be 2 to the third power. The base is 2, the exponent is 3, and you can calculate it and you get a number 8. That's easy, right? You know how to do that. That's very simple. We take that very same relationship and those very same pieces of information and we write them in a different order and call them a logarithm. The other example I want to give you right here, because it's super easy, is 1,000 equals 10 to the third, right? You can see that really easily there. Okay, what if we write it in logarithm form? At first, it just blows your mind. But when we slow down and make the connections, we realize it's the very same thing. We say the logarithm to base b for the number, whatever we're trying to get, is L, the logarithm or the exponent. Okay, so this is the same. So in this case, we would say the log to base 10 in order to get 1,000 equals 3. That makes sense? The base is 10. The number we're trying to get is 1,000. The exponent that we have to put on the base to get that number is a 3. That's what I'm saying here. It's the very same basic information, just presented in a more useful in some circumstances form. Okay, so it's just a question of what form you want. Now, the nice thing about these problems, especially as we're starting out, is that John just gives us practice in going back and forth between exponential form and log form. So he gives us one, and we're going to give him the other. So the first one he gives us is this, 4 equals 3 to the y. Now, we can't calculate that, but we can go, okay, this is the number, this is the base, this is the exponent, right? Just like right there. So now we're going to rewrite it in the other form. We write log, and we put the base down here, 3. The number comes next, that's 4. The log or exponent that we put on 3 to get 4 is y, right? The exponent that we put on 3 to get 4 is y. Beautiful. So this is our answer. We're just recoding things from one language to the other. Example 26.2. Now John gives us the log function and asks us to write it as an exponential. Okay, we know from this, that's the base, that's the number, that's the exponent. So 4 equals x to the m, and that's correct. Make sense? So far, so good, right? All right, sometimes we can actually do little equations and solve them, and it often helps. Let me show you before I say too much more. Solve. All right, what John's telling us is figure out what b is. All right, let's get our heads on straight. This is the base, This is the number we're trying to get. This is the exponent. So what we can do when we have a log equation that we're trying to solve, we can rewrite it as an exponential because our brains find that much easier at this point in the game. So 8 is the number, the base is b, and 3 is the exponent or log. It means the same thing. So some number cubed equals 8, and we see that b must equal 2. Right? Because 2 cubed is 8. That's easy. We knew that. All we're practicing here, we're not doing any new calculations or computations. We're just practicing going back and forth between these two different coding systems, if you will, exponents and logarithms. They mean the same thing, they just format differently. 26.4. Same thing, we're supposed to solve this. Minus 1/2, that's a minus. All right, so again, we're gonna put it into an exponential form so it seems more natural. 9 is the number, b is the base, this is the exponent or log. Huh. That's confusing, isn't it? But you know what we can do? In order to deal with this, because it's sitting on our b, we want our b to be by itself, we can multiply this by its reciprocal to turn it into a 1, and then that will allow us to simplify over here. So look, I'm going to multiply this by minus 2 over 1. Okay, I chose 2 over 1 because that's the reciprocal of 1 over 2. I chose the negative because I want those to cancel out and be a positive. However, I have to do the same thing over here. So it's to negative 2. I won't put it over 1 this time. That's just complicated. So I'll get 9 to the negative 2 equals 1 over 9 squared, right? Because this is a reciprocal or a negative exponent, so it drops it down, it makes the reciprocal, so I get b equals 1 over 81, and that's the correct answer. So, as you can see, yeah, these are log problems, but we're quickly turning them into exponential problems and solving them in a way that's quite familiar. 26.5, and there are 7 in all. Yeah. Solve. Okay, so we're going to rewrite this into an exponential form. The base is 3. This is the number. So I'm going to write 1 over 27 is the number you get when you take the base of 3 and you put an m on it. Oh, okay, well I see 3 to 27, that's cubed, but it's also flopped down. So that must be a negative 3, right? Because 3 to the minus 3 would equal 1 over 27. Okay, yeah, there's a double check on my thinking. So m equals minus 3. Yay. Okay. So the log part of these are not getting harder. We're having to be a little cleverer about our exponents, but that's just exponential business. It's not the logginess of them. Okay, the number is 8. The base is 4. The exponent is x. All right. Now, this one is much easier if we write each of these as a base of 2. 8 is 2 cubed, and 4 is 2 squared, and when we raise it to the x, we know that we multiply it, right? Okay. Now that the bases match, and this is kind of mind-blowing. Now that the bases match, I'll let you write this. When the bases match, we can take the exponents off. What in the world am I talking about? I will show you. See how we made these bases match? They're both 2's. Now we can just say 3 equals 2x. I'm just taking the exponents off. Because if the bases are the same, then they're not going to change the value of the equations at all. We can just focus on the exponents. And so we divide it by 2, and we see x equals 3 over 2. And that makes sense, because if we calculate this, it means we take the square root of 4, which is 2, and we cube it. And that's 8. So that checks. That's what we said it was supposed to do. So this is our answer. Okay, so this is some tricky solving, but again, the drama is in the second 1, 2, 3, 4, 5, 6. How come? Wait a second, I'm looking to see if I forgot one. 4 is that one. 5 is that one. Oh, this is actually 7. Sorry, I did it out of order. Now we'll go back and do 6. Okay, this is our number. No, P is our number. This is our base, and that's our exponent. Okay, so this is going to equal 3 squared, right? The minus sign will flip that back up. 3 squared, so we get P equals 9. That's right. Okay, 26/7. X equals 3 over 2. That's right. And so this one, the other thing I want you to remember about this, I didn't say that right. Don't write that. Here, we had to write as matching bases. Right? That's what we did. We had 8 and 4, and we realized they're both powers of 2. So we wrote them both with matching bases. That allowed us, this was the first thing we recognized, and then that allowed us to do this. That allowed us to take the exponents off and solve them. Okay? You might have just been able to look at this and said, oh, look, if you take 4 and take the square root of it, you get 2, and then if you cube that, you get 8. And you might have just been able to come up with this fraction of your own, but this is a way to step-by-step it through. This is tricky. This last one is the hardest by far. I think the other ones are all pretty straightforward. So if you can manage all the others, then you're fine. We are going to spend a bit more time working on logs this year than we did last year. We're going to review, but what we did today was very straightforward. We just practiced taking log expressions that we could translate into exponential equations and then solve them. Okay, I hope that it was better than what? I hope it was better than last year. I hope it made a little more sense. Okay, I'm done talking. Goodbye.